Hi, everybody. So explanation for quiz 6 here, but if you have not tried to work through these on your own first, please do that because you want to make sure you give yourself the opportunity to try to figure it out on your own. That's much more satisfying. So we'll go through and look at these, and I will post this, and you guys can check through that. If you've got questions, let me know, though, and I will be talking with you. And what else? Oh, right. Kahoot is posted for you guys now, too. The test will be Wednesday, but just let me know if you got questions on it. Okay, so the first one, number 1 here. I've got a trinomial. It's in descending order. There is no GCF other than 1. So I'm going to go right to seeing if it's a perfect square trinomial, which it is not. Neither of these are perfect squares. So I'm going to use the AC method. So A times C, so that 2 times 3 is going to be 6 for our value there. So our middle term being 5x, we want to pick the right pair so that we will get 5x. And we got to get a -3 here. So because actually you can see that with 6 and 1, if you subtract, you're going to get 5x. But with 2 and 3, if you add, you could get 5x. The problem is that with it being a -3 here, we know that they have to have different operations. So it's not going to be both. We're not going to be adding them together. We're going to be subtracting to get there. So try using 2x squared minus 6x plus 1x minus 3. And then now that we've done that substitution here for the -5x, we'll use factoring by grouping. So factor a 2x out of here, leaving behind x minus 3. And it does happen to be just x minus 3 in that second set. So if I'm factoring out the entire binomial x minus 3, and then we put what's left over, right? These are the things that were multiplied by x plus 3, would be 2x plus 1 in there. So you can have those in either order. And if you're feeling at all unsure, remember, just multiply them back through and you can check to see if you got it correct. Number 2. So it is in descending order. I don't have a GCF other than +1. So I am going to check and see, is this a perfect square trinomial? So if I look at this, that's x would be, because that is a perfect square. 25 is a perfect square, leaving me with 5. Now, if this is a perfect square trinomial, then that middle term would be the same as if I do the 5 times the x and then multiply it by 2, which would give me 10x. And that does match what we have here. So we're saying we've got this situation going on. And if we recognize that that's the situation, then we can use the shortcut to say that it's a plus b quantity squared for our factored form. So x plus 5 quantity squared would be the best answer. If you don't recognize that it is a perfect square trinomial, or you don't feel comfortable using the pattern here for the shortcut, then just factor 25, right? 1 and 25, or 5 and 5. And to get the middle term of 10, you got to use the 5 and the 5. It's all addition. So it's either going to be x plus 5, x plus 5, or x minus 5, x minus 5. Well, that second one doesn't make any sense because we have a positive middle term. So you'll get to the same place. Now, sometimes Alex will get weird about this being written as in exponential form or not, so just bear that in mind when you're typing things in for that. Okay, next one there we have, it is in descending order, but I would really prefer to not have a negative starting off my trinomial, so I'm going to factor a -1 out, leaving behind a z squared minus 2z plus 1. So changing the sign on everything inside the parentheses there. And then I really just need to work with this now. So over here in my answer blank, I'm just going to make sure I have that -1. So I don't forget that I've pulled that GCF out of there. This is a trinomial. It doesn't have a greatest common factor other than positive 1 anymore. It does have 1 as the constant there, so it's got to be 1 and 1, right? It's positive 1, so it's either z plus 1, or z minus 1, z minus 1. Well, the only way you can get the negative middle term is if you use the subtractions. And you might have also noticed that this is also a perfect square trinomial, so you could use the pattern there as well. So negative 1 times z minus 1 quantity squared, or negative 1 times z minus 1 times z minus 1. And you could just put a negative sign there instead of a negative 1. You could just put the negative sign there. Number 4, x squared minus 9. It's in descending order. There's not a GCF other than 1. So with a 2 term, we check and see, does it follow the a squared minus b squared pattern? Is this a difference of squares? If it is, then we can automatically factor it into a plus b, a minus b. So since you need to figure out what the square roots are for each of these before you go to the factoring, just figure out what they are if they're perfect squares, right? So x squared, the square root of that is x. 9, square root is 3. All right, they're both perfect squares and they're subtracted. So they match this pattern. So then all we have to do is say, all right, it's going to be x plus 3, x minus 3. And that is it for that one. All right, number 5. Okay, so it's in descending order. There is not a GCF other than 1. And it's 2 terms. So we're checking to see, is this a difference of squares? And it is not a difference of squares. It's a sum of squares. And this is a little one to make sure that you're really thinking about this, because a squared plus b squared is not factorable right now for you. So this one, you just say not factorable. Difference of squares, no problem. Sum of squares, not factorable. That's not going to be until 100. Then you'll learn how to do that. Okay, number 6. Checking for a GCF. And I don't see one. It is in descending order. And then it's a trinomial. Well, then I'm looking at it and I'm thinking, okay, I've got to have to do the a times c method. So a times c is going to be 35 times 10. So 350 is the thing I'm going to be factoring here. So 1 and 350. 2 and 175. 3 does not work. 4 does not work. 5 and 70. Yeah. 6 doesn't work. 7 and 50. 8 doesn't work. 9 doesn't work. 10 and 35. All right. And we got to check up through 350. So I'm just going to quick figure out what that square root is for 350, which is the square root of 350 is approximately 18.7. So if I check my integer factors up through 18, I know that I will have all of the possibilities. All right. So let's see. 11's not going to work. 12's not going to work. 13 won't work. 14. 14 will work because we had a 7 and a 2 as those, it is divisible by both of those already. So 14 and 25. Then I just have to think about 16, 17, and 18. And none of those are going to work. So this is the total list. The one that's going to get me an 11y as you might have guessed, is the last one that we got there. So the 25 and 14. So I would rewrite that as 35y squared. We're going to need to have the 25 be the positive one to make sure that the middle term stays positive. So 25y minus 14y minus 10 would be what I put in there as my substitution for 11y. And now we can go through and use factoring by grouping. So if I look at the first two, I can factor a 5y out of those, leaving behind a 7y plus 5. And the second pair of terms, I can factor out a negative 2, which would also leave me with a 7y plus 5. And then we did get that common binomial, so we can factor that out. And what's left behind would be the 5y minus 2. So for this one, 7y plus 5, the quantity, 7y plus 5, times the quantity, 5y minus 2. And if you go back and multiply that through, if you FOIL it back out, you will get back up to the original one. All right. I am going to have to pause this video in a moment here because the free service that I use only gives me 15 minutes, and I'm on 11 and a half here. So I'll try to break it at a point that makes sense, and then we'll finish up the rest here. Okay, so on the back on page 7, it is not in descending order, is the first thing I'm noticing here. So I need to do that first. So let's see here. That would be 6y to the 4th plus 14y cubed minus 40y squared. And then I'm going to look and see if I've got common factors. And I've definitely got a y squared and at least a factor of 2, because they're all even. You know, you can always go over here and think about 16, 14, and 40 as far as what their GCF would be. So 6 is 2 times 3, 14 is 2 times 7, and 40 is 2 cubed times 5. So we're only going to grab from a full column, and I'll take the lowest exponent of that full column. So yeah, 2 is the greatest common factor for the number part. Don't forget to also pull out the y squared. So leaving behind a 3y squared plus 7y minus 20. And I might go over here and put that 2y squared into my answer blank so I don't forget about that GCF. Because now I need to factor this trinomial. So it is in descending order. I don't have any other greatest common factors. So I'm going to need to look at the AC method. So we're going to be doing the A, which is the 3 times the 20. So we're factoring 60 here. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and then 7 won't work, 8 won't work, and 9 won't work, and then we've covered all the possible factors there because we would start repeating. So which one would give me a middle term of 7? It is going to have to be subtracting because I have a negative constant term. So we're going to be looking at the 5 and the 12 there. So we will grab those. And I will have, 3y squared plus 12y minus 5y minus 20. So making that substitution for the 7y, I'm going to break it into 12y plus minus 5y. And now I can continue going with factoring by grouping here. And I will probably get through this, I'm not sure. And then I will go on to another page here. So we'll have, let's see, a 3y squared and 12y. So I can pull out a 3y, leaving behind y plus 4. And then in the second set of parentheses, we can factor out a negative 5, so minus 5, leaving behind y plus 4. So we do get that common binomial again. So 2y squared, y plus 4, and then the 3y minus 5.